Okay, students. So now we are going to study about the resistance in parallel. So it is the circuit diagram for three resistors R1, R2 and R3 connected in parallel. How it is connected in parallel? So you can check here positive terminal of first resistor, positive terminal of second resistor, positive terminal of third resistor are connected at a single point. Here negative terminal of first resistor, negative terminal of second resistor and negative terminal of third resistor are connected at a single point, and it is in the circuit. Here voltmeter 1, voltmeter 2, voltmeter 3 voltmeters are there to read the potential difference across three resistors, and three ammeters are used to check current flowing through each resistor. Okay, so now let us discuss. When all the positive terminals of two or more resistors are connected to the positive terminal of the cell or battery, here positive terminals of two or more resistors are connected to the positive terminal of the cell or battery, and all the negative terminals are collectively connected to the negative terminal of the cell or battery, then the resistance are said to be in parallel as shown in the figure. So now let three resistors R1, R2 and R3 are connected in parallel to a potential difference V. So these three resistors are connected to the potential difference V here. Now here 3 voltmeters are connected across three resistors to read the potential difference across each resistor. Here this one, V voltmeter 1, voltmeter 2 and voltmeter 3. Here 3 ammeters are connected after each resistance to measure the current flowing through each resistor as shown in the figure. Here 3 ammeters are connected to read the amount of current flowing through R1, amount of current flowing through R2, amount of current flowing through R3. So now it is experimentally observed that when two or more resistors are connected in parallel to the circuit, potential difference across each resistor remains the same, which is equal to the potential difference supplied to the circuit. That is, here total potential difference is V. So here V1, V2, V3, all these potential difference are equal. That means V1 is equal to V2 is equal to V3 is equal to total voltage supplied to the circuit. That is V. Another thing is observed. What is that? Current across each resistor drop. That is, total current in the circuit is the sum of individual current across each resistor. That is, I is equal to I1 plus I2 plus I3. That means if the total current flowing through the circuit is I, then this total amount of current is equal to sum of individual currents flowing through each resistor. That means I is equal to I1 plus I2 plus I3. So on the basis of this experiment, we can calculate the equivalent or total resistance of the circuit. Now derivation of the total resistance or equivalent resistance of the circuit when all the resistors are connected in parallel. As you know that when three resistors R1 and R2 and R3 are connected in parallel to a circuit of potential difference V, so I is equal to I1 plus I2 plus I3. It is experimentally observed. This one experimentally observed. So now we can, from Ohm's law, we know that V is equal to IR. So I is equal to V by R. Now putting this value, that means substituting this value across each current. So what we are going to get? So in case of I, we can replace V by R. In case of I1, we can replace V by R1 because resistors are different but voltage is same. Here in case of I2, we can replace V by R2. In case of I3, we can replace V by R3. So now taking V common, so 1 by R1, V by R is equal to V common, taking common 1 by R1 plus 1 by R2 plus 1 by R3. V cancels each other. So now 1 by R is equal to 1 by R1 plus 1 by R2 plus 1 by R3. So this is the formula for the equivalent resistance of a circuit when two or more resistors are connected in parallel. Here another concept is there. So it is here I am written as notice board. If all the resistors are connected in series, then the equivalent resistance is greater than the highest value of the resistor connected in the series. Suppose R1 is greater than R2 is greater than R3. Then if they are in series, then the total resistance of the circuit is greater than R1. If all the resistors, again second point, if all the resistors are connected in parallel, then the equivalent resistance is less than the lowest value of resistor connected in parallel. That means if R1 is greater than R2 is greater than R3. So R3 is the lowest resistance. So when they are connected in parallel, so the equivalent resistance becomes less than R3. Thank you. So next, on the basis of this formula, series connection and parallel connection, we can solve numerical problems. So I am going to provide some numerical questions you will do in some other copy, not in your classwork or homework copy. Thank you.